This video is for those of you that have chosen to do a chi-squared goodness of fit. And the setup of this is usually set up in categories. So you should have some type of claim that has been made by someone else. In this particular example, the claim is coming from the high schools in a certain county, and they have reported out the percentage of seniors that are taking specific types of coursework. So this claim is that 14% of their seniors are involved in the ACE program, 10% of their seniors are going to the governor school, 20% of those seniors are in dual enrollment classes, but not specifically in one of the first two programs. 30% are working towards an advanced diploma, and 26% are working towards a standard diploma. Now, how this is different from your proportions test is your proportions test usually focus on 1% that's been claimed or comparing two different percentages that have been claimed. Once we get into multiple categories and we're trying to test against all of these categories percentages, your goodness of fit test is going to be a better fit for this. So what this document is here, this is my, this is what I encourage you to use. This is how to get through a Minitab report. Minitab is a software application very similar to an Excel spreadsheet. And the reason I encourage you to use Minitab is because it's going to do everything for you. Now, you can use your calculator to get some of your outcomes, and I'll go over some of those steps at the end of the video. However, your calculator does not transfer what it does into your Word document that you're working in. Minitab will transfer into Word, and then once you had your Word document set up, if you wanted to copy it into a Google Doc or whatever, you can do that. This one also sends it to PowerPoint presentations, so in the calculator you would have to recreate all of that yourself. You'd probably have to put it into an Excel spreadsheet anyway to get pictures of graphs. So doing it in Minitab is just going to have everything done for you and just makes this process simple. So to do a chi-square goodness of fit test in Minitab, first of all, I've set up how this should look in your document. So for any chi-square goodness of fit test, you need your column headings to be observed versus expected values, and the expected values you're not going to know yet. This is something that we're going to have to calculate, but I am going to leave this first box blank. So under C1, leave it blank. In the gray area under C2, this is where I'm going to list all of my observed values, and in C3, I'm going to put all of my expected values in this column. Whatever your different categories are, you're going to list those under C1, but again, leaving this gray space blank. So beside number 1, we will record the ACE, beside number 2, the governor school, number 3, dual enrollment, followed by advanced, and followed by standard. Okay. All right, so my observed counts are the ones that I actually counted in each category. So for ACE, I found that 32 of the seniors in my school were in ACE, 29 were in GOF school, 73 were taking dual enrollment, 95 were going for advanced, 85 were going for standard diploma. And now I need to compute what I would have expected to get if this claim is indeed true. So what you'll notice is I have tested, I have 311 students total in my sample. So if the claim is that 14% of seniors are in ACE, out of my 311, if I do 0.14 multiplied by 311, I would have expected to get 43.54 in that ACE area. So it looks like for my school, we've got a little under what we should have expected if that claim was correct. For governor school, the claim says that 10% should be in governor school. So if I do 0.10 times my sample size of 311, I would have expected to get 31.1 in that area. So again, I'm coming up a little under what I would have expected to happen. For dual enrollment, 20%, so 0.2 times 311, I would have expected to get 62.2. So it looks like I've got a little more than expected in that category. For advanced diploma only, I've got 30%, 0.3 times my sample size of 311. I would have expected 93.3 in that area, so close, but I'm still a little over. And then for standard, I would have expected 26% of my 311, so 0.26 times 311, I would have expected 80.86 in that category. So I'm a little over for that category as well. So mine are not exactly what I would have expected to happen, which is never going to happen in a sample. So what I need to figure out is this different enough to say that the claim is incorrect, or is it just sampling variability? Is it just a little bit off? If I took another sample, would these values be different? Are they close? Okay, and that's what we need to figure out. So first I'm just going to do some summarizing statistics, and I've given you a list of steps right here that you can talk yourself through in order for this to do everything for you. So first I'm going to go up here to stat, and I'm going to come down in my options and choose tables. For step number 2, I'm going to choose the chi-square goodness of fit test one variable, which is right here. So first you're going to click, and yours is going to be empty right now. I'm going to take that out so it looks like what you're looking at. All right, so you're going to click in the white box for observed counts right here beside it. And then you're going to, step 4, come over to highlight the observed variable, and then come down below it and click select, and that will place observed in your white box. Step number 5, you're going to click in the category names box, and you're going to choose C1, which is where we had all of our category names. Hit select, and then down here at the bottom for step 7, we are going to click proportion specified by historical counts and click in the white box. You're going to choose the expected value and hit select, and then you're going to press OK. So the chart for the contribution to chi-square, you can look at this to see that the ACE program is the one that is really different. So if I show that there's a difference here, this is the category that I would come back and look at. So you can right click in this and save it to your report if you want to. It's really only going to be important to me though if I get a statistical significance in the difference of the categories. I'm going to X out of it right now. I can always come back and do that again if I need to. But you have a graph right behind it that says chart of the observed and expected values. I would have this in your report. We can also see that the ACE was the biggest difference compared to what we expected to get in all of those categories here. So I'm going to right click in the gray area here, and you'll notice that you have some options where you can send that graph to Microsoft Word. You can send it to Microsoft PowerPoint. You can also copy it. I haven't tried to copy and paste it into like a Google Doc. I always just work in Word. So I'm going to send that to Microsoft Word. And you'll notice that it just automatically pops up in my Word document. So I don't have to recreate anything. I don't have to transfer anything. It does it for me. Okay. And you can drag that and put it wherever you would like. Once you have that up, you'll notice at the end of each section I have this little double star here, and what that double star is going to do, it's going to tell you what you need to talk about. So in your report, what paragraph do you need to type? In your presentation, what do you need to discuss about this graph? So what you want to talk about is, what do you see when you compare those expected values versus the observed? And on this scale, it doesn't really look like there's much difference between it. We're getting pretty close to what we expected to get. It does look like I've got a little more ACE kids than I expected. There's a larger gap there, but still not really big. It looks like we had a little more little less dual enrollment than what we expected, but still not a very big gap. But you want to talk about what those gaps look like. You also want to talk about what you want to try to prove, okay? So what we want to try to prove is that there is a difference here in these two things. Is that a big difference? So before we run this test, we do need to check conditions that we're going to be able to do that. You need to have randomness, which I think I totally skipped, so let me go back up there. When you start this out, you do need to provide an introduction paragraph that's explaining your question of interest, why you chose that question. You also need to describe in detail what type of sample you've chosen, and you should have already done that in the sampling or the experimental design videos that you watched, whatever you chose out of that. So your randomness you should have already completed from those first videos, and that's already been taken care of. The second condition is the large count condition. All of your expected counts should be greater than or equal to 5 to run this test. So these expected counts here are all greater than or equal to 5. And your 10% independence condition, your sample size times 10 in this case would be 3,110. That should be less than the population. So this would have to be a very large high school in order for this to work. If this is not met, then you would want to adjust your sample size until it does work. If it works, then just make a statement in your Word document and checking off these three that these three have been met. So once your conditions have been met, you can run your test. And the good thing about the chi-squared is it's already been done for you. If you just X out of this chart right here, I don't need to save it because I've already sent it to my Word document. Your test has already been run, so there's nothing extra that you need to do. So you just need to make your conclusion in your Word document. So if you're describing what your conclusion means in the context of your problem. So what you were trying to prove is that you did have a difference. Basically, your null hypothesis, your H sub 0, I'm not going to take the time to make that a sub number, but your null hypothesis would have been that the claim was correct. We want to assume that they were telling us the truth right out the gate. And then your alternative hypothesis would be that the claim was incorrect. Trying to prove that it is different. So your computer test will print out all of the contributions, which we can look at. This is the first graph that we deleted, so they're still here. We can look at those. It also prints out your p-value, which is going to be your focus for your final conclusion. So if that p-value is less than 0.05, we're going to reject the null hypothesis. That means you do have evidence of your alternative hypothesis. If your p-value is greater than 0.05, we're going to fail to reject the null hypothesis, which means you do not have evidence of the alternative. So in this case, my conclusion would be this. My p-value, I always want to start with that value. That p-value is 0.264. And when I compare that to my alpha level of 0.05, now again, your alpha level can change, and we're going to talk about that in the final video. This is based on your confidence level, which we typically use 95% confidence level. So that 0.05 is the other part of 100%. So since 0.264 is greater than 0.05, then I need to fail to reject the null hypothesis. And what that means is there is no evidence of the alternative hypothesis, which was us trying to prove that the claim was incorrect. So there is no evidence that the claim is incorrect. You do not want to say the claim is correct. You want to word that in terms of your alternative hypothesis. So there is no evidence that the claim is incorrect. We do not see, this is not a true difference. This is just sampling variability. Okay. Now, if your test does show a difference, you want to talk about where you see the biggest differences. So in this case, we would not talk about that. But if we did get evidence that the claim was incorrect, we would want to talk about the fact that the ACE program here is the biggest contribution to chi-squared. So that's where we're seeing the biggest difference between these between these categories. The next biggest difference was in the dual enrollment. We had already seen that on the graph. We could see that this was the biggest gap and this was the biggest gap. But for our conclusion, these were not big enough to really say that they were differences at all. So your final paragraph is going to explain what types of errors you could have made in your study. There's going to be a separate video explaining that. And also being able to explain if you changed your alpha level, what that would do to the outcome of your test, and would you use that? Would you make that change to make your argument more convincing? And that's going to be a separate video in itself as well. So make sure before you wrap up your report that you have watched the video for types of errors and the video for changes in the alpha level. Now, if you are just dead set on using the TI84 calculator, it will do this for you. Let me pull it up real quick. Sorry, my computer is slow. Okay. You can do chi-squared in the calculator. Well, okay. If you put your information into stat first, if you go to stat and choose edit, if you have any old information in there, you want to go up to the L's and just hit clear. Do not delete them. Clear L3, come back down. It'll be gone. Go up to L2, clear, come back down. Go up to L1, hit clear, and come back down, and everything should be out. So I'm going to put my observed counts in L1, 32, 29, 73, 95, and 85. Then I'm going to put my expected counts into L2, 43.54, 31.10, 62.20, 93.3, and 80.86. And then I can do the chi-square test in my calculator. So if you go to stat and then use the right arrow twice to highlight test, if you scroll down to number or letter D, it is the chi-square goodness of fit test. So I can choose D. It's going to ask me where I put the observed counts, and that was in L1. The expected counts are in L2. That was automatic, but if they are not there, L1 is in blue above your 1 key, so you'll have to hit second 1 to put an L1 there. To put an L2 here, you would have to hit second 2. All right. I want to do that though. So DF is the degrees of freedom. So degrees of freedom are always one less than the number of categories that were in your study. So I had 1, 2, 3, 4, 5 categories in my study. One less than that is 4. So the degrees of freedom here I need to change to 4. and then I can calculate the test. Okay, so it will give me the p-value, which in this case says it's very, very close to 0, which is different from what Minitab did. Not sure why. I'll have to play with that. But this does have a 4.31 e to the negative 8. Remember that e to the negative 8 means multiplied by 10 to the negative 8 power. So that would move the decimal 8 places to the left, which is going to make this really, really, really close to 0. So that would change my result on this. Let me make sure I got my observed and expecteds right. Oh, that's why I put a 3 there. Let me redo that. That's supposed to be a 32. So let me run that again. Stat test, letter D, degrees of freedom 4. There we go, now it matches. Okay, so p-value is 0.264, just like we got in this is 0.265, but it's close. My contributions are listed right here. I could scroll to the right if I needed to see all of those. So it gives you the same information as the Minitab. You're just going to have to transfer everything yourself. And you'll still have to make the same conclusions and all that stuff. So if you have any questions, let me know. Those of you in Danville, if you have questions, just see one of your math teachers down there. And good luck.